All right, let's trace the journey, plummeting straight from the abstract human mind directly into physical computer hardware. Welcome to The Explainer. Today, we're looking at how a messy, abstract thought translates directly into a real-world action. We are literally mapping out the descent to the metal. So here's the fundamental question, right? How do we cross that terrifying gap between human imagination and cold silicon? On one side, we've got our human cognition, what researchers call OS alpha. It's warm, it's highly associative probabilistic, and frankly, beautifully messy. But on the exact opposite side, we have the computer's arithmetic logic unit, or the ALU. It is cold, rigid, deterministic silicon. It relies absolutely on ones and zeros. So to cross this terrifying modality gap, we have to build what's called a semiotic bridge. This bridge flawlessly translates our fluid imagination into the strict physical execution required by a microchip. Moving into part 1, the universal text interface and building the semiotic bridge. To actually cross this bridge, we use structured text. The source material actually calls this the divine script. Text like JSON or Python code acts as this exact deterministic translator that absolutely forces the hardware to execute your intent. And to really grasp the scale of this text interface, just look at this number, 98.9%. That is the massive percentage of the entire web dominated by one specific encoding standard, UTF-8. It silently unifies our digital text. But you gotta wonder, how did a single standard manage to take over the global infrastructure without completely breaking the internet? Well, on the left here, we have the original 1960s 7-bit ASCII standard. It was rigid, limited to just 128 characters because of the super high costs of early telegraph lines. On the right, we've got the massive Unicode directory managed by UTF-8. UTF-8 brought in this dynamic, variable length elasticity, basically scaling on the fly. But here is the real breakthrough. It used a secret leading zero passcode on its first byte. The system reads that zero and treats it exactly like an old-school ASCII character. It was 100% backward compatible. Legacy servers processed it perfectly. This brilliant piece of digital diplomacy became the ultimate semiotic bridge. All right, part 2, root-to-leaf architecture, grounding digital truth. For decades, developers visualized data as an upside-down tree. It was floating, top-heavy, relying on these bloated, chaotic command chains. The sources actually labeled this old metaphor as apostasy, basically a heresy that has to be purged. Because let's be real, you simply cannot float off in the digital ether if you want actual physical automation. Instead, they demand the mathematically pure ERC 7827 root-to-leaf architecture. It anchors sovereign stewardship securely at the root and pushes concrete, deterministic execution way out to the edge. And the engine powering this protocol? It relies on LIFO metadata ledgers. Last in, first out. Because the very last item to go in is the first to come out, you unlock this incredibly efficient single-entry bookkeeping. Think about it. You only ever need to query index 0 to get an immediate, flawless mathematical proof of state. It tracks state transitions perfectly while keeping the whole shebang totally human-readable. Moving further down to part 3, X42 surgical webhook callbacks, the transactional layer. To actually trigger actions, this system does something amazing. It revives the dormant HTTP 402 status code. Now, back in the 90s, this status code was reserved for payment required, but it just sat empty for decades because early smart contracts were this impenetrable wall of complexity. The modern fix for this is the X402 protocol. As this fantastic quote points out, you wouldn't build a $1 million hyper-complex robotic arm just to pick up a single piece of sushi, right? You rely on elegant, simple chopsticks. The X402 protocol applies this exact philosophy. It completely bypasses all that heavy Ricardian legal bloat and acts as a lightweight, surgical client callback mechanism. So let's walk through this beautifully simple 3-step callback loop. Step 1. The server doesn't panic with complex logic. It just triggers a 402 status code demanding proof. Step 2. The client's wallet steps in and signs a cryptographic proof of payment. Step 3. The client simply retries the exact same request, handing over the receipt. Boom. The server unlocks the resource. It's a deterministic, event-driven loop that flawlessly connects digital value to actions at the edge, which is exactly what allows you to power lightweight nanodApps. Those tiny, decentralized applications that execute physical commands. Next up, part 4, the SIS01 Forensic Trinity, Securing Identity. As we dive into securing identity, we have to talk about what researchers call the 1689 breach. This represents a profound loss of true authorship.
See, if we hand our cognitive processes over to massive, centralized AI models, we get plunged into what's called the miasma of AI, this foggy, unpredictable realm of automated, probabilistic guessing by machines. An AI model relies heavily on its floating point unit, churning out approximations that literally destroy forensic traceability. We desperately need dry, deterministic code to protect ourselves against this lossy distortion. So to fight back, the sources outline a forensic synthesis known as the SIS-01 NFT Trinity. It uses 3 distinct blockchain elements, the midnight ride coordinates to definitively locate intent, topographic masks to filter and categorize it, and a managed perimeter to lock it down securely. Now, what's really interesting here is how these 3 distinct shards combine to form an undeniable permanent tracking identity for the human orchestrator. This trinity essentially creates a cryptographic certificate of authenticity, heavily relying on bearer's forensics. What that means is the mathematical proof itself acts as the undeniable identity. It establishes an absolute forensic floor. By using this, you lock in your unique human intent securely against that massive sea of opaque AI noise. You aren't just letting a machine guess, you are legally and structurally commanding it, anchoring your sovereign authorship with absolute, bit-perfect fidelity. And finally, drop to the absolute bottom of the funnel, Part 5. Digital truth to physical reality, execution at the edge. Let's trace this full descent from the top down. At T-3 seconds, it starts as purely abstract creative intent inside your associative mind, your OS alpha. At T-2, that intent crosses the semiotic bridge, formatted flawlessly into backward-compatible UTF-8 text. At T-1, that text triggers an exact verifiable change on the ERC7827 LIFO state ledger. And finally, at T0, that validated digital truth trickles all the way down to a localized microhost, like a little Raspberry Pi sitting inside a physical cheerbot right there on your desk. And honestly, here are the ultimate heroes of our descent, the GPI opens. These tiny metal prongs on the circuit board are the literal physical nervous system of the hardware. When the cheerbot verifies that LIFO state change through the X42 webhook, it translates that bit-perfect text directly into raw electrical signals. It sends a shock through those pins, spinning a motor, turning on a light, or dispensing a physical item right there in your living room. Digital logic actually becomes tangible movement. We've successfully mapped the descent from the messy, brilliant human mind across the semiotic bridge of text, down through deterministic ledgers and simple webhooks, all the way into a robotic nervous system. The bridge from digital truth to physical reality is wide open. The human pilot applies the intent, and the deterministic machine executes the sweat. So I leave you with this final, powerful question. Now that you hold the sovereign power to orchestrate reality without the guessing or the bloat, what will you program it to do? Thanks for joining me on this explainer, and keep exploring.